Hey there, science fans! Today, we're diving into the fascinating world of heat and how it affects matter. Let's start with two processes you've seen countless times: boiling and evaporation. Boiling is like a party in a pot of water. We heat the water, and it gets super excited. When the temperature reaches the boiling point, bubbles rise and burst at the surface. That's the water turning into steam. Evaporation, on the other hand, is a stealthier process. Think of a puddle drying up after the rain. The water molecules are quietly escaping into the air as water vapor, even though the puddle isn't boiling. Why the difference? Boiling happens throughout the liquid when the temperature is high enough. Evaporation happens only at the surface, and it can occur at any temperature. Pretty neat, huh? Now, let's talk about what happens to matter when we heat it up. You know how a balloon expands when you blow air into it? Well, something similar happens to most materials when their temperature rises. We call this phenomenon thermal expansion. Imagine the atoms and molecules inside a material as tiny dancers. As we heat the material, we're giving these dancers more energy. They start to jiggle and vibrate faster, needing more space to move around. This causes the material to expand in size. Temperature plays a key role here. The hotter the material gets, the faster the particles move, and the more it expands. This principle is used in many everyday applications, like thermometers and bridges. Thermal expansion can happen in 1 dimension, 2 dimensions, or even 3 dimensions. Let's break it down. Linear expansion is when something gets longer when heated. Imagine a metal rod getting a tiny bit longer when you heat it up. This is linear expansion in action. Area expansion, or superficial expansion, is when a surface gets bigger. Picture a sheet of metal expanding in both length and width when heated. That's area expansion. Volume expansion, or cubical expansion, is when an object expands in all 3 dimensions: length, width, and height. Think of a balloon inflating. That's volume expansion. Section 4. Expansion in different states of matter. Solids, liquids, and gases. Solids, liquids, and gases all expand when heated, but they do so differently. Solids have a fixed shape and volume, so their expansion is usually small. Think of a metal bridge expanding slightly on a hot day. Liquids don't have a fixed shape, so they expand more than solids for the same temperature change. That's why thermometers work. The liquid inside expands as the temperature rises, moving up the tube. Gases have the most freedom to move around, so they expand the most of all. Heating a balloon full of air is a great example. The air inside expands, making the balloon bigger. Why the difference? It all comes down to how tightly the particles are packed together. Solids are the most tightly packed, followed by liquids, and then gases. The more space between the particles, the more they can expand. Section 5. A simple experiment. Seeing thermal expansion in action. Want to see thermal expansion in action? Here's a simple experiment you can try at home. You'll need a balloon, an empty glass bottle, and a bowl of hot water. Here's what you do. First, stretch the balloon's opening over the bottle's mouth. Next, place the bottle in the bowl of hot water. Then, observe what happens to the balloon. What you'll see. As the bottle heats up, the air inside expands. This causes the balloon to inflate. You've just witnessed thermal expansion firsthand. This experiment illustrates several key concepts. Thermal expansion. The air inside the bottle expands when heated. Volume expansion. The air expands in all directions, inflating the balloon. Heat transfer. Heat is transferred from the hot water to the bottle, and then to the air inside. Section 6. Conclusion. The big ideas about heat and expansion. So, there you have it. A whirlwind tour of boiling, evaporation, and thermal expansion. Remember these key takeaways. Boiling and evaporation are both ways liquids can change into gas. but they happen under different conditions. Thermal expansion is the tendency of matter to expand when heated, caused by particles moving faster and needing more space. Linear, area, and volume expansion describe how objects expand in different dimensions. Solids, liquids, and gases expand at different rates, with gases expanding the most. Keep exploring the world with a scientific eye, and you'll be amazed by the wonders of heat and matter.